Hey team, welcome to another 0 to 1 billion channel episode, the channel where we talk about how you don't need to be a CEO to have impact on the world. And in this episode, I bring you some great information on why you don't need to reinvent the wheel when trying to learn data science in 6 months. So if any of that sounds interesting, please stay tuned and watch this video. Alright, so as I mentioned in the previous video, in this week, I did everything possible to learn chapter 3 and 4 in the Intro to Statistical Learning with R book, and it's going absolutely great. I've managed to read those chapters and do the problems, and I'm feeling a little bit more confident in my ability to do those statistical learning methods. Now, it did get a little tricky, specifically when using Jupyter notebooks. Now, before I get into the video, that was kind of the summary, and later on I'm going to talk a little bit more about why you don't need to reinvent the wheel while learning data science in 6 months, where I talk more about why I'm using certain tools to better my learning speed, tools that have already been made by other people and shouldn't be reinvented. Alright, so this is the point in the video where I'm going to go more in depth with everything that I learned, and then go into how I used someone else's GitHub. So let's get talking about chapter 3. In chapter 3, as mentioned earlier, it was on linear regression, and linear regression is something that we've done, previously in high school. We've done a little bit of intro to stats in college, and is the kind of statistical method that is most commonly thought of when you think of statistics. And that's because it's a very simple method, but it's very, very useful. In fact, it's useful at least a third of the time to tell you what's going on. It's really useful when you get into hypothesis testing and just, confidence intervals, and it's kind of an approach that most people start off doing because it is so effective. Now, let me tell you a little bit about what we learned in the chapter. Again, this was kind of review for me, but it was much needed because in chapter 4 we went deeper into logistic regression and multiple variable regression, multi-class regression, and those were things that I definitely needed to review linear regression before we get to that. So chapter 3, we learned all about the formula for linear regression, and then we went on to learn about hypothesis testing. Now, hypothesis testing is actually a fairly simple idea, but it's kind of non-intuitive to people at first. What you do is you get a hypothesis, and the hypothesis is that there's actually no correlation between your x and y variables, and then you get an alternative hypothesis, which is basically the hypothesis that there is relationship between your x and y variable. And in fact, that's usually what you're trying to find out, but you use this kind of null hypothesis as a kind of way to prove that there is, because if you say there isn't and there is, then you're wrong, in which case you're right. So that's the kind of thinking we do in stats. If it's a little confusing, don't worry. It's a very easy concept to get a hold of, especially if you think about the theory behind it. If you set the b of 1 to 0, right, no hypothesis that there's no relationship between x and y, your x would then, in the formula, will then become 0 because b of 1 is multiplied times x. So that means that whole term, the whole x term, gets removed from the formula. So then you have y equals b 0 plus some error, in which case there's no x, therefore there's no relationship between y and x. And so that's kind of the behind the scenes thinking of why null hypothesis is such an important way of doing hypothesis testing. Okay, so that's enough about chapter 3. Now, in chapter 4 was actually super interesting. It was all about classification. Now, classification is different from quantitative variable because this doesn't really include numbers. You could be anything from a true or false, success or failure, a fraudulent claim at a bank, or a truthful claim at a bank, spam email or ham email, which is good email. And all of these things, you don't only want to classify them, but you also kind of want to predict the percentage in each classifier. Or you might even want to have a system kind of tell you, for example, in a bank's case, which ones are the fraudulent claims and which ones are not the fraudulent claims, and which is the one with the highest percentage that it's a fraudulent claim, which one's the lowest percentage and then you can decide what your threshold is for dealing with that later on, using either more systems or more people to look at it in depth. So if you think about it, it's very important not only to get the accuracy, but also to have a good idea later on about, what your mistakes are. Now, in this chapter, we learned all about how to set up the model for this. If you have a case where it's only a true or false, or only a yes or no, you can actually just use a linear regression. You change, or at least a better way to say this is you map each yes to a 1, each no to a 0, and then you do linear regression, for example, saying that y, you estimate y at 0.5, and then you do your model and you see what the results are. Now, one thing that you're going to find out actually is doing a linear model, sometimes you might get probabilities that are very, very wrong, or at least don't make sense in the case. You might get negative probabilities even. So one thing that really helps us in this case is logistic regression. Now, logistic regression is kind of just like linear regression. All it really does is make it go through the e and put everything to the power of e. What this basically ends up doing is you get a number that's always between 0 and 1. The exact formula, if you're curious to know, is actually e to the power of the linear regression over 1 plus e to the linear regression. And you can quickly see how that formula will always give you a number between 0 and 1. And this actually helps you predict in much better cases the probability of success or failure, a yes or no, in the data set. Now, one of my favorite things in this chapter was all about case sampling control. And this kind of blew my mind in the beginning because I hadn't realized that many studies were structured this way for this exact reason. Now, what case sampling control allows you to do is, if you're going to be using logistic regression, you kind of are able to figure out using certain formulas how you can get a population of data, or you at least, let's say you have a population and you know prior what the mean probability for this population's case is. So for example, if you have a disease and you know for this population that the mean probability of people getting this disease, the cases, is, let's say, 5%, then you can actually grab a sample of people that have the cases and don't have the cases. Or really, this is what happens when you have a really rare disease, is you can get a bunch of people with the case and then just look for random people that don't have it, and create a sample that is actually representative of the population. Now, funny enough, this doesn't happen automatically. You actually have to go through a formula, but let me explain this deeper with an example. Let's say there's a rare disease in Africa that we're studying, and we know it affects 5% of the population, but we can only find very few people with the actual disease, and so we try to gather as much people with this disease as possible to get the most amount of data. But then we get a bunch of people randomly that don't have the disease, and we end up kind of with a skewed percentage of people in this sample that actually have the case. So let's say we got 100 people that have the disease, and then 200 people, 300 people that don't have the disease. Now we end up with a sample of 3 or 400, but the probability of you having the disease in the model is actually going to be extremely high. It's almost 50%. It's going to be more than 30%, because it depends on how many, cases to non-cases you've got. But because we know the mean probability of you having this disease actually in the whole population, we can actually use that and put it into a formula and put our sample into a formula, our sample cases in our sample controls, and actually end up with a resampling of the population that's actually much more accurate and gives you much more insight to what the actual probabilities would be in the population, and not just a very skewed sample. Now, what does this mean? Well, this means that a lot of epidemiologists specifically can use so much less resources just getting as much people as possible that have these rare diseases, instead of doing long time studies of 20, 30, 40 years hoping that certain people get the disease in the population, so that they have the the most precise sample, most random sample possible. This allows you to kind of bypass that and just get the most amount of cases as possible, get some control, and then fix it later. So that's great. Now, moving on to the final part of this video, which is all about how you shouldn't reinvent the wheel when trying to learn data science in 6 months. One of the things that I've realized is, we're shortly coming towards the end of these 6 months, and there isn't time for someone who's learning data science very quickly to go over how to make or how to reprogram everything in data science. You're not going to go over how someone programmed something like a plot visualizer, or a something that's already been done, like a linear regression. Now, we can easily reprogram that from scratch, but what's the point? You're trying to learn data science as quickly as possible. So when trying to learn data science within 6 months, I found that GitHub is an amazing place to find lots of examples of projects, or even homework in this case, that other people have done already, that they have completed it, they have checked the work and moved on, and posted it to allow other people to see it. Now, in this case, for this book is actually written in R. And so a lot of the examples in the homework and in the labs, which are just exercises that they go over in the book, are written in R. And so if I wanted to move that over to Python, I would have to program a lot of stuff from scratch. But why would I do that when I'm in a time crunch? So I decided to just go on GitHub, try to see if anyone else has done this work. And it turns out there has been. It's a very popular book, therefore multiple people have kind of ported over the exercises from R into Python, and therefore I'm able to go through their work and grab what I need in order to be successful, in order to be more efficient. So this is really what I mean by trying not to reinvent the wheel. There's no reason to go out and try to reprogram all these, or port all these modules from R into Python if someone's already gone and done the work. That's not the important part really of what we're trying to learn. We're trying to learn statistics and statistical learning, and the problems associated with that, the benefits associated with each model, not really how to port over things from R to Python. That's not really our job. And therefore, let's not try to reinvent the wheel here, and let's just use the resources that are available for us. And that's exactly what I managed to do. I'll post the link of those GitHubs that I've been looking at doing the homework below, and I really recommend you check them out. And to kind of bring this into conclusion, try to, in your data science journey, learn as much as you can from other people's work as you do from books or from online, or just from you trying to learn things by yourself. Other people sometimes can lead the way, and as I've mentioned earlier, try not to reinvent the wheel when learning data science in 6 months. So I hope you enjoyed this video, and give me a thumbs up if you have, and I'll see you next time. Peace.